So to begin with, thank you for coming here to this talk, and I sincerely hope that you are enjoying the conference as much as I am. So the title of the talk almost says it all. It's Anatomy of a Credit Card Stealing, RAM Scraping, POS, or Point of Sale Malware. Uh, Needless to give you an introduction on this, as you have been, you have been hearing news about multiple vendors, merchants for the last year or so. In this year, we saw Target, Neiman Marcus, Michaels, B.F. Chang's. Last week, we saw Home Depot. And again, I'm not here to sort of point fingers at any vendor or anything like that, but I'm just underlining the the problem that we have and the amount or really the size of the problem that we have. So to get started, a little bit of an introduction. My name is Amol. I work for Vulnerability Labs at Qualys. That's my Twitter handle. If you want to reach me out, ask me a question, share the slides, whatever. So in the next hour or so, what we are going to do is we'll start initially by introducing some concepts on POS systems and credit cards. And I know a lot of you might already be pretty intimately familiar with these, but just so that all of us are on the same page, we'll cover a little bit about POS systems and credit cards. Then we'll look at the attack working. How is the attack carried out? What does the attack do? How does the malware scrape memory and so on and so forth? That will be followed by a demo. So what I have here is actually I have a pretty functional working POS system right here. I've basically converted my laptop to a POS system. What we'll do is we will study how these techniques work, not just by studying the malware, because most of the time you don't have source code for the malware. You have to go to the assembly code, reverse it, and study how it works. So for ease of understanding, I have written a similar code. So yeah, it's basically a malware. But then we can study it better because I've written it and I can explain it a lot better if I have the source. And last but not least, we'll look at some of the countermeasures, some of the things we could do as merchants, as banks, as credit card processors to make sure that things are, well, I guess as much safe as they can be. So we have a pretty packed agenda. Let's get started. This is a slide from last year's Verizon data breach, and it has in the columns various techniques that were used for data breaches. So the first column right there is POS intrusions or point of sale intrusions. And you can see that about 75% was in the accommodation industry, so basically hotels. So this report is from last year, and POS malware, as you know, is nothing new. It has been hitting us for quite some time, but last year and especially this year, we have seen a lot of uptick. So last year, accommodation or hotels, they put it at 75%, while retail at the bottom. So here they say accommodation for POS malware 75%. Last year, retail was only 31%. But I bet when they come up with this data for next year, retail is going to jump a lot because of all these vendors that I just mentioned and that you all hear in the news almost on a weekly or monthly basis. A new vendor is compromised. And the fun fact to see is that even last year, POS intrusions were pretty high up there as compared to all other intrusions. I mean, they have things like insider misuse, miscellaneous errors, denial of service, or cyber espionage, even web application attacks. So I would say here POS intrusions were pretty much neck to web application attacks if you sort of add all these numbers. Of course, in accommodation, last year there were, I guess they said only 1% web application attacks. But web application attacks were pretty high in utilities, transportation, and certain things. So what exactly is a credit card? Now everyone know what a credit card is. We all have them in our wallets, in our purses. We carry them, but I think these are the three main types, and what we will be talking about them today. The first one is a very familiar one with a magnetic stripe on it. Second one is we are getting a little bit familiar with it, with a chip on it. The chip cards are predominantly used in Europe, in UK, and some of the South Asian countries. And the third type is basically your pay pass or pay as you go, where you really don't have to swipe your card. You just bring your card near this terminal and it blinks, and yeah, it has processed your transaction. There is also one more type, which is you can pay from your phone, your NFC-based device. But that, I mean, we haven't seen a lot of adaptation for that yet. So today we'll be primarily talking about this one, which is the most commonly used magnetic stripe-based credit card in the US, and also a little bit of this, because some of the banks in the US have started issuing cards with chips on it, and we'll see what does the chip do and what does it all mean. So the slide here says CVV2, CID, and we'll go into details of this in a few minutes. So this is what a common POS terminal looks like. Now again, no surprise here. You have your typical touchscreen monitor, you have a processing unit, you have your cash register, a printer, and the most important, a credit card reader. Now that is something very similar to what I have got here. It's just that it's connected to my laptop. This POS hardware is sold by a variety of vendors. If you buy the entire package, it would cost you about $1,000 to $1,500. Often it is integrated with a lot of accounting software and so on and so forth. But interesting thing to note, and which is very important for today's talk as well, is a lot of these point of sale terminals or cash registers, if you may, they run on Windows. So beneath all that credit card reading, all that POS processing, there has to be an operating system. And the most common operating system used in these cash registers is either one of the blends of Windows. And I'm not saying that's necessarily bad, it's just a FYI. So that was about the POS terminal. Now let's take a sort of a quick peek at what does your credit card have. So your typical magnetic stripe credit card has some data, and that is this data. We'll go into details about it. So there are 3 tracks on that magnetic stripe, and this is a public information. I got the image from this link, but you can find this information pretty much anywhere on the net. So track 1 is basically, this is the density of the tag. So it has 210 bits per inch. It's basically how much amount of data it can store. It can store 7 bits per character, and as a result can store 79 alphanumeric characters. Track 2, it's 75 bits per inch, stores 5 bits per character, and can store therefore about 40 numeric characters. And there is again track 3, but that is almost never used in financial types of credit cards or debit cards. So we won't really refer to that in this presentation. Remember, the same magnetic stripe credit card can be used as your hotel card. It's just programmed differently. So if you actually look at how credit cards and magnetic stripes came, there was, I think, an engineer at IBM, and this magnetic strip is pretty similar to the magnetic strip you have on your old style records. If you remember, before compact discs, I mean, now a lot of people don't even remember compact discs, but before compact discs, there were these audio tapes that you put in, and you can record stuff on it, you can play on it. And it has it has 2 wheels basically, which turns the magnetic stripe over the head, which reads the data. So credit card magnetic strip is almost exactly the same. You can almost cut the magnetic strip, paste it on a plastic. In case of the audio, there is a moving mechanism to move the magnetic strip on the head. Here on your credit card, there is no mechanism to move it. That's why you swipe it. So instead of moving the tape, you basically swipe your card and it has the same action as moving your audio tape on the head. So anyway, this is what the credit card, what your credit card holds. And if we take a little bit look further deep inside it, this is again public information. You can find it anywhere on the internet. This is basically track 1 data. So what does this have? This is the format of how track 1 data is stored on your card. The reason we are going a little bit in detail in this is because this is very important in understanding later on how the malware works and how it is able to scrape credit card numbers in memory. So let's take a little bit of a detailed look. It starts with a start sentinel. It's nothing but just some characters to tell that, hey, now what follows after me is the credit card number. So that's the start sentinel. It's usually a %sign. After that, what you have is a field separator, because there are multiple fields. The field separator is usually either a caret or a B. After that, what follows is your PAN, or your primary account number. This is basically your credit card number, the same credit card number which is engraved on your card. It's in the magnetic stripe. It has another field separator saying that, okay, the PAN field has ended. The next field is your name field. Now, this is track 1 data. So as we saw before, it can store alphanumeric characters, so it can store your name. So it is 26 alphanumeric characters name, and usually there is a slash in between your last name and your first name, followed by another field separator, followed by additional data. Now things get a little interesting here. So the additional data, the first 4 characters of additional data are your expiration date, and the next 3 are your service code. The service code can be multitude of things. It basically tells if this is a credit card or a debit card, or in which situations it could be used, and it's pretty much bank specific. So that's the service code. And last is the most important part, is your 1-digit PVKI, or PIN verification key indicator, or your CVV, or card verification value. Now, there is a CVV number also written on your card, on the back side of the card. That number is different than this number. This is the original CVV. The number which is written, physically printed on your card on the back side, is CVV2. Now, why do we need these 2 different CVVs? Is what happens is when you swipe your card, all these details along with the CVV go for authorization. They make sure that the credit card number, name, and everything matches up with CVV, and they give you back basically a transaction code saying the credit card is accepted or not. The CVV2, which is on the back side, is never sent to credit card authorizing body when you swipe the card, and we'll see soon why it exists. Again, sort of a end sentinel saying that this is the end, and LRC, which again we'll look at it in a few minutes. So this is basically what your track 1 has on the back of your card. We went a little bit into details because, as I said, this will be greatly helpful for us when we look at our malware. CVV2 is similar to this. If you remember, it cannot hold alphanumeric characters, so it only has numbers, and it has your primary account number, expiration date, service code, CVV, and all these things except your name. And that is also enough for the transaction to go through. Your name is not really a mandatory field for the transaction to go through. The reason to have 2 tracks is so that if, let's say, for some reason the card reader cannot read the first track or cannot process the first track, it reads the second track and tries to authorize the transaction using second track. So that was about what sort of data is stored on your card. Now let's look at some transaction types. So one is a card swipe transaction, very easy to understand. When you swipe the card, all the data on the magnetic stripe is sent. Second is the card not present transaction, is when you use the card at Amazon or any online retailer when the card is not swiped. That is the time you enter the CVV2, which is on the back of your card. And for card not present transaction, you need that CVV for authorization to occur. So even though if you knew what the CVV1 on your magnetic stripe is, that would not be allowed if the card is not swiped. If you, let's say, buy something online, you have to enter the CVV2, which is on the back of your card, not the CVV1, which is on the magnetic stripe. So it has basically a legacy. Initially, there were no card not present transaction. Every transaction was just a swipe. Then all the online thing came, and they said, okay, now how do we verify cards if it's not swiped? How do we know that the person physically has the card? So they printed a number on the back side, called it CVV2, and that's what is now used for online transactions. So mostly we will focus on card swipe today, because that's where the POS malware comes into picture. So a lot of things have been done for making sure that the credit card data is secured. It's secured at rest. It's secured while it's being transmitted. It's secured when it is transmitted. And don't read too much into this, because this just illustrates various things that we have done to secure card data at rest and card data in motion, or when the data is on the move. But these things become a little bit blur or do not apply to the POS malware, because it steals its data from RAM. So although the credit card, most of the time, a lot of vendors, merchants, no one really wants to store credit card data unless they really have to. So credit card data is just processed in RAM, encrypted, sent encrypted, decrypted. Maybe people who have to store it, it's stored in an encrypted format. But even to do this encryption and this decryption, the data has to be in clear text somewhere in memory. So when it's basically read from your card, before it is encrypted to be sent, it is in memory for a short amount of time in plain text format. And that is where RAM scraping or these POS malware hit, is they steal this unencrypted data from the POS systems while it is unencrypted in memory, before the POS process could possibly encrypt it and send it away for authorization. So let's take a look at some of the attack scenarios. So what happens is a lot of attacks today. I should have changed these slides based on a few incidents from like a couple of weeks ago. But traditionally in the hotel industry, what happened last year is that since these point of sale devices are nothing but your Windows boxes, a lot of people use them to check your email, check your Facebook account, and in that you get a phishing email. You click on that email and you have the POS malware now downloaded to your machine. In some of the recent incidences this year, the POS malware hits your POS system by the way of remote administration. So a lot of these systems have they are outsourced for administration to other companies. The owner of the system never really is in charge of administration. They have third-party companies doing administration, and therefore they have a lot of remote control protocols like remote desktop or VNC or whatnot running on the POS system, so that administrators can remotely connect to these systems and possibly upgrade some software, do some maintenance. And some of the recent attacks that we have seen, and I think even US CERT issued an advisory on this, is the attacks were carried out by just simply brute forcing the remote admin interface. Now, it's a common sense practice not to expose these remote administration interfaces to the entire world, to the internet. You should sort of go through VPN or some secure channel to administer it. But well, as you know, there are different things in theory what should be done, and the way they get implemented are completely different. So these are some of the attack scenarios through remote desktop or through phishing by which the malware can get on the POS system. Once it gets on the POS system, it just waits for a customer to come and scan or use one of the magnetic stripe readers to scan their cards, and then basically RAM scraping takes place. RAM scraping. So what the malware does is it continuously is monitoring your RAM for credit card data. A lot of operating systems have mechanisms where one process cannot really access other processes' data, but then we'll see now in a short time how a lot of that can be bypassed, by which the malware process can sort of hijack or not really take control, but at least read other processes' memory, the POS processes' memory, extract credit card from it, and then it can send it through some command and control to the mothership. So this is basically the attack scenario. We'll be focusing mostly on this when the card is swiped and when the RAM scraping takes place. How the malware gets on the box is by some of the scenarios that we just talked about, and we won't go into further details of that. So how does a RAM scraper attack work? As I mentioned earlier, most of these systems are Windows systems, and what I'm going to do is I'm going to walk you through some of the system calls that the malware calls. And if you are Windows API developers out here, it would be very easy for you to follow the process, or to sort of trick the, I wouldn't even say trick the OS, but to follow these different APIs to get what you want, which is basically attaching to other process and get information from that process. Initially, the plan was to make the source code available for free, because I don't think it's, well, at least that was my plan. But in the light of recent events, when I went to my boss, he said, well, that may not be a good idea, because although you are saying it's not that difficult, anyone can do it, I don't want to, well, your code or our code to be used in a bad way. So sorry, the source code would not be available, but I'm giving you the API calls, and most importantly, the sequence of the API calls. So if you are in that domain, it won't be really that difficult for you to study what's going on. And you can, of course, hit me on Twitter, or contact me by any of the, email me, whatever, and I can, after looking at your credentials, easily help you out with it. So the first and the foremost thing that the POS malware does is it tries to find the POS process which will have the credit card. Now, modern day operating systems, they have at least 4 GB of RAM, if not 2 GB of RAM. And for the POS malware to, on a continuous basis, just read the entire contents of RAM may be a little bit time consuming. So what they do is they already have a list of, let's say, top 20 POS system softwares that could be used. You can just download these software and look at the way they register at Windows, and then just basically look for those processes. So you don't basically enumerate all processes on your machine, but you just target those top 10 or top 20 or maybe even top 50 or even all POS vendors, instead of basically targeting all processes on your POS system, which would be time consuming. So you find your POS process which will have the credit card number. That's what the malware would do. It would call basically enumerate processes to enumerate all the processes. It would open process, it would call enumerate process modules and get what is the module name for that process, and then get the module base name. Now this can be done in a variety of ways. This is just the way that I chose in my code to find the POS process, but this can be on Windows done in a variety of ways. And I know the API calls just by the name are a little difficult to use because there are a lot of parameters, a lot of structures to be filled to pass to these APIs, but that's where, that's what I'm not basically giving out. So you find the POS process which has the credit card data. Then what the malware does is it elevates its own process by and gives itself a very peculiar access which is called as SE debug name in Windows. So when the malware has that level of access, that is required for it to do 3, which is basically connect to a process. A lot of Windows boxes, the POS system runs as administrator, or the requirement for this is basically when the malware is running, it has to run with the same privileges as the POS system, which is very easy, pretty easy under Windows, because most of the time the POS system is running. If that is not possible, there is a little bit of a detour, which is basically you could also inject your process into another process, and there are certain calls for that, and thereby get to our step 3. Okay, and this is done by your, basically first you open your process token, you look up what are the privileges for your process, and then you adjust your process token accordingly. Then the step 3, after you elevate your own privileges, after the malware elevates its own privileges, the step 3 is pretty simple. You just open the POS process. This is as simple as opening like a box of gift, because you already have found the process, you already have enough credential, enough access. You just open the process. It's a pretty simple call, just one call open process to open that process. And then, well, our familiar thing, which is then you scrape the RAM. Now you get access to the virtual memory of that process, and you basically just go through, if you are not very intelligent about it, you would just go through all the virtual memory of the target process that you are targeting. So you look into the process memory byte by byte, or you don't have to really do it byte by byte, because you are looking for 16-digit credit card number with the track 1 format that we saw earlier. So you are looking for that %sign, that B sign, that PAN number, which could be, most probably it's 18 digits, 16 digits, but can vary. Then you are looking for those field separators. So you can do that very easily by a set of regular expressions to sort of scrape, or to do string match or regular expression match to see if any of the track 1 data is in the process memory of the process that you are targeting. And you can do that by virtual query EX and read process memory calls under Windows. So it sounds all simple, but it is still like finding a needle in the haystack, because as I said, even on 32-bit Windows, there is every process gets a large amount of virtual memory. On 64-bit Windows, every process gets really humongous amount of virtual memory. So if you just start looking at all memory segments, you would lose the race. The why I say that is because the POS process, which has your credit card, they are not, I mean, they know what's going on. They are trying to, as fast as possible, encrypt that credit card number and send it over for processing. Or as soon as the POS process, your point of sale terminal, reads it, it tries to send it for authorization as soon as possible and zero out the variables in which the credit card number was written. So, I mean, these guys are also not, it's not their first rodeo either. So they are trying to do it as fast as possible. Send the credit card number for authorization and zero out the memory or the variables in which the credit card number was stored. Now I think everyone here has some background on programming, so you know what I mean by a variable. Like the credit card number is stored in some sort of a variable. So even though you send it for processing and you free it, sometimes the OS may not write zeros in that part of memory location. So before freeing that memory, you yourself make sure that you zero out the variable, and then you free the memory. So it's like finding, as I said, a needle in the haystack. So what the malware does, the tricks that the malware does, is that it looks only for memory that is committed. So in that humongous amount of virtual memory that every process has, it looks only for memory segments that have this flag on it, the mem commit flag on it. And what basically that tells them that this memory is committed. This is not just virtual memory, but there is some physical memory, some physical RAM, which is in the OSS mapping table mapped to this virtual memory. So then your virtual memory all of a sudden doesn't look that big. It is restricted only to the physical memory that is allocated. Other things that you could do is, or the malware basically does, is that it ignores memory with this mem image flag. Now what is this mem image flag? Now what it does is the credit card number will not be in the executable part of your code. So any process, when it's loaded into memory, it has instructions which are not basically, which cannot be changed. These are just instructions, that's the process. So it skips that part. It skips various other things where resources are kept, like images and bitmaps and so on and so forth in your memory. So it skips all that parts, and it only searches in the parts where variables are stored. I mean, that's the easiest way to put it. And the other things it could do is it would, once if it's successful, it tries to remember the memory addresses where it found the credit card number the first time inside that virtual memory, inside that process, so that next time it has to do that, it can optimize itself by first going to those addresses, because if ASLR, which is a technique by which addresses are randomized by Windows, if that is not enabled, then most probably the OS will load your variables at same memory locations. So there are some of these tricks that the malware could do to optimize itself to get to that credit card number quickly before the POS terminal has a chance to encrypt it or zero it out. And then, as I mentioned, it does this pattern matching on track 1 and track 2. We already saw what this person B and this caret and this question mark, all that mean. So it just does this regular expression that give me anything that starts with, let's say, person B has a caret in it and another caret in it and has a question mark in it and has a bunch of numbers on it. So if you are familiar with the regular expression, you know it's pretty easy to write a regular expression to match this pattern. So after getting the number, so let's say it did find this pattern and it was able to extract this credit card number from memory. What it does is it applies this LUN algorithm. Now this is not a malware algorithm. This is a pretty well documented algorithm to make to tell you if the number that you have is a valid credit card number or not. So if you take the credit cards from your pockets, your purses out, and apply this algorithm on it right now, it should tell you, yes, it's a valid credit card. It's pretty simple. You take the original credit card number, you drop the last digit, you reverse the digits. So it's basically you just drop this 5, you reverse the digits, you multiply odd digits by 10. So 5 becomes 10, 8 becomes 8, 9 becomes 18. Every odd digit you multiply it by 2. Did I say 10 earlier? I think it's multiplied by 2. You subtract 9 if the number is greater than 9. So 10 becomes 1, 8 remains 8, 18 becomes 9. And then you again add all the numbers and you get a number. And when you add that number to the original number that you dropped, the mod 10 of it should be 0. So it may sound a little bit involved, but in reality, this is like a quick and dirty C code that I wrote to verify it, and I'm pretty sure most of you can write a code, even more optimized code than this to verify if your credit card number is valid or not. So it's not that difficult at all. And this function, if you just copy paste this in your compiler, should work as is. And since there is no proprietary information here, we can give this out. So demo time. That's how, I guess, the malware finds your process, POS process, attacks it, gets the credit card number, validates it, and spits it out. So what I have here is a working point of sale terminal. And what I'll do is I have a credit card. Let me just invalidate this transaction. So let me just go home, discard changes. So I'm like some guy working at this shop. I come here, I clock in. My name is, let's say, Bill. Bill clocks in. And you as a customer come here. They say, this is a sports shop, by the way. They say, I want to buy some item. I click on make a sale. And what the person is buying is, let's say, a baseball hat, 40 bucks, pretty expensive. Some bike helmet, 65 bucks. Oh man, I would never go to this shop. 65 bucks for a bike helmet. And then the customer gives me his card. Now I need a volunteer here. Can someone give me their card, please? No, I'm serious. No. I'm just kidding, because your number and your CVV and basically everything for that card will appear on the screen. So this is the card. It's expired, so feel free to write down the number, but it's expired. So what the customer does is they give me the card, I swipe it. This is a pretty cheap, like $20 device you can buy brand new on eBay. So I swipe the, I forgot to do something. I need to say credit. Total is $82, and currently I'm running this in demo mode, so it won't send this card for authorization. So that's what it's saying here. This is a demo account, no money is transferred and no data, if you can see that blinking thing, because I don't want a bunch of invalidated transactions. So what I do here, I swipe the card and it says, okay, do I want to collect any tips or whatever. So now let's just assume that the malware is running in the background. Instead of the malware running in the background, this is my Visual C++ directory where I have built my program. Actually, let's take a little bit peek into, well, let's see, we do have some time, so we can take a quick peek at the program while the customer is waiting for the tip to be entered. So as you can see, it's a pretty small program, not really that big, just a few lines of code. Here, this find POS PID is the first step, which is we find the POS process. And in this program, I have hard-coded it to find this POS process that I am targeting, the demo POS process. But as I said, you can target like the top 50 POS processes or top whatever you want to target. Then you do that by your enum process and all those calls. You enable token privileges, so you make your own privilege as SCDebug. Now this is not a system call, this is my own function which calls a bunch of other functions, which does that. Then you open the process, as I said, just open it as a gift, and then you basically find locales, which is you basically look for credit card numbers. So your find locations is pretty much like this. You look for the credit card number, you look for, then you extract the name, then you extract the expiry date, then the service code, the PIN verification number, the PIN PKI, PVV, CVV, and basically at the end of the day you just print all that. So when I compile that, it becomes a binary. And now here, if you still recollect what happened here, the customer came, he or she swiped his credit card, and basically I run this process, and it dumped out a bunch of things. So it first of all dumped out the memory location, it dumped out the credit card number 407411. You cannot really see here, but you just have to take my word, it is the credit card number. And here a demo would be useful, which is if someone really gives me their credit card number, that would come on the screen. But I don't want any of you to do that. It puts out your expiry date, your service code, your PIN verification number. So basically you saw that the moment I pressed enter, it immediately was able to find that. And that was because of all the optimizations that my program did. And I mean, I'm no genius. The malware guys are a lot better than at least me. So they also have a lot of such optimizations. So it really works very quickly. So this is a 64-bit machine, but the processes are 32-bit processes. So the point here is it does work really quickly, and even if you have a machine with a bigger memory, or maybe the POS process allocates a large amount of memory, I don't think it would matter, because it just takes, I haven't even calculated how fast it is, because the moment I hit enter, it just pops out the credit card numbers. It pops the same credit card number multiple times, because in the process memory for this software, it is right now stored at multiple places in multiple variables. So that's the reason it finds it at many places. And well, this is some improvement that I need to do, is it is also putting a little bit of garbage data before and after the number. So, but yeah, that's the demo. The POS process, which is a different process that I ran here, was able to sort of steal the credit card number which I swiped in, I'm sorry, the malware process was able to steal the credit card number which was swiped in this POS process. So I say, let's say no tip, I'm really, I'm a bit cheap. So, and the transaction went through. I mean, this is a demo process, so it really didn't went through, but it will go through. Now, if I run the process again, it still does have the credit card numbers, but what I've seen is many times the POS process immediately clears out the memory, and then I cannot find the numbers anymore. So I'm really astonished that this is actually happening the first time here live, that I can still find the credit card numbers, maybe because it has not cleared out the memory correctly. But usually when I do this demo, after the transaction goes through, the POS process clears out the memory, and then the credit card numbers are gone again. Maybe I just need to go home, and then it would do that. So return or discard changes, and it can still find it for some reason. So it's still there in the memory for the POS process. So coming back to our presentation, this is the last slide. What can we do so that this does not happen? As a POS business owner, if I have a point of sale terminal, I may be a small mom and pop shop, or I may be a large vendor. The first advice is use POS only for its intended purpose. So last year, in a lot of travel industry, the way malware got on the POS systems, because people were using their POS systems to browse the net, to check Facebook, to click on links. I mean, a link in an email, it's such a tempting thing that very few people can resist the urge to click it. So defer to that temptation. Don't click all the links you get in your emails or anywhere. Secure remote management software, this is more advisable for this year, because a lot of attacks this year that we saw are from this type of attacking the remote management terminals. Measures to protect against insider threats. So now there is this ID theft center.org. They said that last year about 11% of POS attacks were from insider threats, where really at a 7-Eleven or someone gives a USB stick, tells the cashier, put it in, and then give it back to me, and that's it, he gets a $100 note or something like that. So you have to make sure those type of low-tech sort of attacks don't happen either. And also we are out of time, but next we have lunch, so I'll continue just a little bit. Best practices: make sure that you scan your POS systems for vulnerability scanning, for auditing, patching. Enable end-to-end encryption hardware. So what I mean by end-to-end enable hardware is there is a little bit expensive hardware that you get, where when you swipe the card, it is before sending it to the POS, it encrypts it and sends it to the POS. And there is special software here which can decrypt it, or which can just say, other type of hardware can just do the entire transaction on the pin pad, and so only a transaction ID is sent to the POS. So the credit card number is never really sent to the POS terminal, only a authorization code is sent. So I think you should consider investing in that type of hardware. Deploy smart cards. Now this is, I mean, the core of all this is, yes, there are credit cards, there are this, that, but the core problem here is that the credit card number and the information needed to authorize it is stored on your card in plain text. So that is the core sort of Achilles heel of this. Smart cards have been used in Europe for a long time now. They have a chip inside a card, so your credit card number or information is never sent. The chip itself does or enables, aids in authorization, so only a transaction ID is sent. But in the US, we are stuck with these cards for some time. It's like a chicken and egg problem. The issuing banks won't give me smart card because they say none of the vendors accept smart cards, so what will you do with your smart card? And the vendors say that, well, you don't have a smart card, so what will you do even if I have a chip and pin terminal? All is not lost. Things are changing. There are some rules and regulations coming by which they have to issue us smart cards in the US as well. But again, the rules that are coming, and it's a little complicated, we can chat about it offline. We are not getting the entire chip and pin as we have in Europe. We are getting something called as a chip and sign, because for some reason they think that US customers are not intelligent enough to remember the pin. So we are getting the chip and sign, which is not like a full-fledged chip and pin, but it's a lot better than at least what we have now. But still we'll have this problem for some time now, because a lot of the chip cards, I've got a chip card from my bank, but it also has a magnetic stripe behind for backwards compatibility. If I go to a 7-Eleven, which cannot handle the chip transaction, they still has to swipe it. So until you have that magnetic stripe and plain text credit card data on it, I think you are, or I guess we are vulnerable. POS software vendors, they can, I mean, this software that I showed you was actually pretty good. It was very good in my tests in zeroing out the data as soon as it sends data for processing. But there are there are tons of POS software that I've seen that really don't care, and data remains in memory unencrypted till you close the process, and you never really close the POS process, it's always running. What can we do as credit card users? And this is where I really need your help. I was not really able to find much of a technical solution. What can we do here? Most of the credit card processing happens here on trust. When I give my card to a server at a restaurant, he or she takes it off my site, and anything can happen, because this $15-20 device can easily be used to swipe everything from your card. As I said, again, in Europe it's a little bit better. No matter what restaurant you go, really upscale, low scale, they bring the processing unit to you, because at the end of the day you have to enter a PIN for your credit card. So it's never is out of your sight, it's always in your hand. I'm not saying that all they have is good, because there are pros and cons. There in Europe, if you somehow lose your PIN, if someone in London, you know, there are cameras everywhere. If someone captures your PIN on a camera, then the bank would not back you. You have to pay the credit card charge, no matter how big it is. In the US, we have a lot of more consumer protection, so that if your credit card number is stolen, you just call them. As long as they don't suspect a fraud, you haven't called them 100 times before, they would reverse the charge and you don't have to pay for that thing. So there are pros and cons, and again, we could have another one of our session on what is better, the chip and pin or just the chip and sign for consumers, a non-technical session where we could weigh in what is really good for consumer and consumer protection and that sort of thing. So with that, that's my Twitter handle. Please send me any questions. I do keep updating a lot of stuff, not only just on POS security, but generally in security. So you'd find some of my comments interesting. And we open up for Q&A. Hmm? The chip cards, you mean? The NFC-based cards where you just bring the card close to the device. So I have actually not done much research into it, but in that as well, what my again, I don't want to give wrong information, so I haven't done much research into it. I can look, that is my sort of next thing, to look into those type of things. Apple, as you know, they announced their latest payment card systems on phone. Android had their NFC thing. So I don't know. Sorry, I haven't looked into it. Yeah, go ahead. So, mm-hmm. 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 It is definitely a little bit more secure than the magnetic stripe cards where everything is clear text. It is a lot more convenient as well because, I mean, if you forget your wallet, I mean, nowadays you can forget your wallet, you would never forget your phone. So you could still pay using your phone. The only, I wouldn't say drawback, but we would have to wait and see the adoption. As in, as long as there are enough vendors accepting those type of transactions, that would work. But I still would carry my normal credit card because while traveling somewhere, I'm sure I'll find a vendor which just takes the magnetic stripe, has this type of a reader and won't process that. So, yeah.
Actually, we're all getting chip and sign, not the chip and pin. Can you just briefly describe the difference of when the chip and sign is less secure?
So it's less secure in the sense there is no pin to enter. In chip and pin, what happens is you enter a pin even for your credit card transaction, not just debit card. Even for your credit card transaction, you enter a pin, and the chip itself validates there if the pin is right for that credit card and just give you a transaction ID, success or not, which it sent and card process. Chip and sign, from what I understand, and it's again a new thing in the US which is being adopted. So it's not, even I haven't tested it firsthand. But what chip and sign is, the chip would help in encryption of the card and things like that, but there would still not be any pin attached to it. So the problem of plain text credit cards could be solved by chip and sign, but again, it would basically help in generating a transaction ID which is passed over. Does address the RAM scraping problem. Yes, yes, yes. Go ahead. Uh-huh. Uh-huh. Oh yeah, I mean, a credit card reader, I mean, there are a lot of legit purposes. They can be used for like your keys of your hotels or your parking lots, and it's, I mean, it's not really anything. I mean, you can, yeah, it is pretty legit to buy this type of a device or sell this type of a device, because these things were not regulated before. Mm, yeah, yeah. I mean, go ahead. So it could do many things. I just showed you the way I did it in my program. It could find the POS process by, let's say, even the title, which is shown in the Windows. Or in Windows, every program registers itself with a certain name. So it can try to find that name for that process. In Windows, there are a lot, like literally many ways to find the process. If you just look at find process call, you can check what arguments it takes and then figure out how you can give those arguments to that call. Yeah. All right. Well, great. Thank you very much.